Hey there, geometry guys. Hope you're doing well. Jumping back into schoolwork, so we've got a couple things today and tomorrow and next week. Then Friday you'll have an assessment over all of it, so kind of take a look at the next little bit of time. Today we're gonna go over 8.2 with tangents. Just kind of review. We took some notes last week before Easter, and now we're gonna kind of dig into that a little bit more. With practice, and then take some notes on arc, measure, and length. So a lot to cover. We'll kind of buzz through this first part pretty quickly though. So tangent practice, to start off with, remember a tangent line is one where some line that touches the edge of a circle only on one point. Remember, if it goes through 2 points, that's called a scalar. So those are really the only two options. So this point, or this line here that's yellow, is tangent, which means it is creating a 90-degree angle with a radius that it intersects with here at this point, which means we have a lot of right triangles, so you need to think about that for your homework tonight. If you're identifying a triangle, it's probably a right triangle within circles here because of this tangency thing that we have going on in the rule that it creates a 90-degree angle. Okay, if you have two lines that are tangent to the same circle at two different points, but they have the same endpoint even outside of a circle, it means that the length of these two sides are congruent. We talked about that. So there's a lot of things that could happen with that, and again, that could be any point. I mean, it could be a short little guy right here, still tangent to 2 points on a circle, and they share an external point. Those would also be congruent segments to each other. So there's a lot of things there that can happen with any external point here. Okay, we talked about that. Let's see what else we talked about. We talked about common tangents. If a tangent is common to, if a line is tangent to two different circles, then it's called a common tangent, as long as these two circles are in the same plane. So we could have all sorts of different lines. And we also talked about if a circle is on either side, and it could be this way, you could have one line and your two circles on either side. Don't know if we mentioned this. So these two circles here, I guess I should give them some names. Circle A and B are called internal because they are, here's the point of tangency, and it is, they're both circles are on the same side. So one has to be kind of inside the other. You could have a larger one here, and if they share the same point of tangency, they're on the same side of that line. They're called internal tangent circles. And then if they're external, so if you had circle B and C, they still share that point of tangency, but see how they're on other sides or opposite sides? They're called external tangents, and that is supposed to be an A. Remember, I can't write it all on this, so just imagine that that's an A. I hope it's getting a little bit better. I got a new stylist in the mail with some birthday money, so hopefully it'll work a little bit better than my finger, and we'll see how that goes. I hope that helps. Anyway, side note, back to what we're doing. Okay, so that's kind of that. Your homework over this section, you have homework tonight that kind of covers 8.2 and 8.3. So it's just a short amount from each one. Remember, if you have a triangle inside of your circle with an external point here, so for example, this blue circle or triangle here, remember a squared plus b squared equals c squared. Pythagorean theorem is so helpful. That is why getting a right triangle is like the best thing ever. So, within reason. Remember, look in your notes. We put some formulas in like this. If you're solving for A, remember A and B are side lengths. C is always the longest point. It's your hypotenuse. Has to be across from that 90-degree angle. Okay? So if you're looking for A, it's c squared minus b squared. We talked about these. I'll just throw them up real quickly. in case you still need it. Remember to do the inside first. You got to square it, subtract it, and then take the square root. And if you're doing C, it's just the square root of a squared plus b squared. Okay, so look for those if you need that. Most of the time you can just leave something under the radical. So like if you had square root of 11, you can't do anything else with that. You might have like 5 times or 25 times some square root. Look back on those radicals if you still need a little bit of catch up on that. Okay. I know there's a really quick breeze, just a refresher since it's been all of Easter. I want you to try that homework. Go back and watch 8.2 video again if you need to. We are jumping into arc, measure, and length. Those are 2 separate things, and they're easily confused. So I want to take a look at this circle here. We have some inscribed, we have an angle inside of my circle, and again, this is a little bit different. Don't confuse it with a central angle. That has to do with a polygon. So if we have a polygon like this, that's a central angle, but this is just called an angle inside of my circle, or our arc measure. Okay, so get rid of that. Okay, so arc measure is actually the degrees. Like it's going to be in degrees, or you might call it theta, and that's like an unknown degree. If we don't know how many degrees, we'll use theta inside there. It's kind of like an X, but for degrees or measurements with our angles and things like that. So the arc measure is actually a number, and it will be in degrees. Okay. When we get to trig, it might be in radians, but we'll always have some arc measure there. Now, arc length is different. It's actually like it'll have to be in inches or centimeters or something like that, and it's not going to be squared. It's just going to be units, because it's actually like how long, if you had a little guy here and he was traveling and he was walking around and he went from this point to this point, how far would he go, kind of thing. Okay, and again, that is going to change based on a few things, based on the degree measurement, right? This part right here, how wide is this, and your radius, right? So if you had a smaller circle, getting off here a little bit, but we'll get back to it. So if I had a smaller circle, I could have, I don't know, let's call it 60 degrees. That's not exactly, but we'll just assume. This distance here will be some measurement. We would have to know the radius in order to find it. But if you had a larger circle, you could still have this same angle measurement, or the arc measure, and because the radius here is a lot longer than the distance that this guy has to travel to go all the way from one side to the other along that curved surface, the arc length is going to be longer, of course, right? If you have a bigger pizza measured in diameters, you're going to have more crust on your pizza than if you had a tiny, tiny little personal-sized pizza from Pizza Hut, and you wouldn't have as much crust, even if it was cut the same degree. Anyway, all right, so let's get rid of that and talk a little bit, how do we find some of those things? I hope that helps clarify the difference between the two, not to be confused with each other. If we have an arc measure, we can add and subtract these kind of in similar ways that you would expect. So actually, before we kind of calculate them, let's talk about that. This is going to seem obvious, but again, remember, a lot of this geometry stuff, we just have to have some postulate for, I don't know, some reason to state the obvious, because that's how it works here. So, all right, let's see. If we had, we can call this angle 1, angle 2, angle 3. If I have this red angle here, I could say, I don't know, let's call that 45 degrees. It looks about like that. Let's call measure of angle 2, we'll make it yellow, and let's say that it is 105. And let's make this angle 3, we'll make it teal, and I'm going to try to make this come out pretty evenly. Let's call that, oh, that's not going to be, 30 would come out perfectly, but not accurate what I drew. I don't know, let's say 40 then. It doesn't really look like 40, but imagine with me, remember? Okay, so of course, if you have this small little red arc measure, we could know what that is. We could know the angle or the arc measure for the second one, and for this third one we could know the arc measure. But what we know based on the arc addition postulate is if we were to add these two together, let me get another color here. If I were to say, hey, what is this big arc measure from here to here? Well, can't I put 1 and 2 together just like I did with the angle postulate before? If you add these two angles together, well, all we're doing is doing the same thing except putting it inside of a circle. Does that make sense? So here, measure, we should call this A, B, and C so we can make a little more sense of this. So the measure of AC is how we're going to mark it, and that little hump on top is going to be called my arc, is equal to the measure of arc AD plus DC, right? If I add this section and this section, I get the whole thing. So in this case, I would get, I kind of drew over that, but I guess it's probably like 150. Okay? Does that make sense? We can add those together? All right. So that's how we find arc measures, and we can add and subtract them as you might suggest or see. Now, one thing I want to point out is that if we were to draw this all the way across, we're going to get to this a little bit more. If this is a straight line, that is half of the circle. It's called a semicircle, so we know that it's 180 degrees. So I could find this missing angle right here just based on the fact that this is a straight line. Make sense? I would have to take, and I might be jumping ahead of myself here a little bit, but let's roll with it while we're here. 180, and take away 45, so I get 135 degrees. Could put that right in here. Okay, makes sense? Okay, arc length is a little bit different and slightly more complicated to find that distance. Again, we're going to refer to it in distance. It could be in inches or centimeters or meters or any of those types of things. And it has this formula right here. I'm going to kind of move down a little bit so we have some more room here, and I'm going to rewrite it. Make sure you put this part in your notes. The arc of a circle, if its radius is r and if its circumference is c, we'll talk about that, will be called a given length. And let me make this the same color as before. So the length of the arc. Now, it's going to be talked about arc length. You might say, what is the length of some arc? We know that it's referring to arc length. And if it talks about degrees, then we know it's talking about arc measure. Okay? So that's kind of how we're going to see the difference between these two. So arc length is going to be, this is a little bit similar to our sector. So if you didn't like those before, and they're still kind of coming up here a little bit, it's whatever degree measurement divided by 360. That tells me the fraction of the circle that I'm dealing with. Okay, fraction of the circle that I'm dealing with times the circumference. The circumference would be all the way around, and if I were to take a fourth of that, then it would be this little section here, right? A fourth of it, some fraction. In this case, fourth would probably be written as 90 over 360, because, pretend that's a 0, because that would be a 90-degree angle. I don't know if that makes any sense there. But whatever the angle measurement, and divide that by 360 gives you the fraction of the circle, multiply it by your circumference. Now, I need you to recall that circumference is equal to 2 pi r. Okay? So another way to write the length would be, so I want us to have this formula here. I know this is really messy on the screen, I'm sorry. Write that formula, and I want you to have this formula also. Make sure it wouldn't hurt to have the circumference written down, just as a quick refresher. So 360 times 2 times pi times the radius of that circle. Okay, so let's practice a little bit with that, and we might get to that in a minute here. Let's take just a couple more notes and we'll practice that. I'm jumping ahead. Okay, so some unique things that we need to do are just kind of naming them. You could have unique angle measurements or arc measures, and we need to be able to identify them. So like I said before, if you have half this black line here, it's straight. So I know that this is 180 degrees. That's half of the circle, or half of 360. And it's unique because it's half exactly, and it's called a semicircle. So these are some of the vocabulary words that you need to know. A semicircle. Now, we could kind of like if we had a right angle, right? It's 90 degrees. We called this an obtuse angle, right? It was more than 180 degrees. And then we had an acute angle, and it was less than 180 degrees. Well, that's what we're talking about. We're going to name them as a major arc. A major arc is more than 180. And a minor arc, you guessed it, less than 180. Okay? So this major arc comes from here and goes all the way around to this line here. Okay, so pause this video if you need. Make sure you get this vocabulary in as well so that you know kind of where we're at with things. Okay, and there's only one more type of circle that we need to address, and it's also pretty obvious. I'm going to draw two circles. If you have two congruent circles, my goodness. Okay, pretend those are congruent. That means that their radius is the same length, okay? Let's just imagine with me, okay? All right, so if you have either the same circle or two circles, and you have the same measure, then their arcs are also congruent. So if this is 20 and this one is 20, well then their arc measure is going to be the same. And vice versa, if their arc measure is the same, then if their arc length is the same, I said the wrong thing, which is going to throw you off, I'm so sorry. Their arc length, if that's the same, how far it takes to travel, then their arc measure is the same. And if their arc measure is the same, then we could determine that the arc length is the same. So, and that's only if they are either on the same circle or if their radius is the same. They're identical or congruent circles, right? So if you had 20 degrees here and you had another 20 degrees over here, well, this arc length is the same as the other, okay? All right, so those are called congruent arcs because they are congruent. All right, let's keep going. Okay, so we talked a little bit about our arcs and our measures, and we talked about a minor arc and a major arc. If I know that this is, let's say, 100 degrees, let's make it easy on us here. If I know this is 100 degrees, this is a minor arc, right? It's less than, there we go, minor arc, less than 180 degrees. And the major arc that corresponds, whether it goes with it, would be what's remaining. And this would have to be 360 minus 100, right? Whatever's left over, this would be 260 degrees. This is my major arc. So what we could assume, which again is kind of obvious, if I had another circle and I had a congruent minor arc, so let's say we had the same, again, the circles have to be congruent. If I had the same radius, if I have 100 degrees here, if I have some minor arc, well then its major arc is also going to be the same, or that could be referring to its arc length also, either way. All right. Now the degrees will be the same no matter what your radius, but we're just talking about congruent circles right now so that we can also talk about the arc length. All right, so let's practice a little bit. Take a second. This is, I guess, technically an example. Write this in your interactive notebook. Pause the video if you need. We're going to talk a little bit about how do we determine some things. We've got to look at our endpoints. This would be circle B. We would name it this way because of its center point being named B. And I have some radii here, which means I have some arc lengths and different things that we're going to talk about. Let's talk about finding some minor arcs. In your homework tonight, you're going to have to say, hey, I've got this arc, and I need to determine if it's major or minor, or if it's a semicircle. So what if I had AF? AF. It's going to look like this. written like that. And this is going to be a minor arc. What if I had AE? Also minor, right? It's less than 180 degrees. What if I had AC? This would be a semicircle. Now, often the semicircle is going to be referred to as arc ABC because I need to know that the line comes through that point. Okay? You'll just need to be able to identify it either way. If it has this arch, it's referring to some sort of an arc. Okay? And you'll need to determine some to be minor, major, or a semicircle on your homework tonight. You're also going to need to determine their measurements. So let's look at that a little bit. Let's find some measure of these arcs. So I know this one is 30, and I know this one is 20. That's given to me. I want to know, well, I guess let's fill these in. I want to know AE. So A is right here. The measure of that is 30 degrees. What about AD, this whole thing right here? Well, according to the addition postulate, I know that I can put this pizza slice and this one together. So I have 30 plus 20, or 50 degrees. Okay? All right, what about the arc length of AE? Do I have enough information to find the arc length? Not quite. I need its radius, right? Remember, this is like how far do I travel from here? Okay, so let's give you a radius. Let's say that it is 4. Just pick a number. Okay, the arc length, go back to the same color, of AE, we'll use our formula. Do you remember what it is? It's that degree measurement divided by 360. That gives you a fraction of the circle times the circumference of the whole circle. Now, you can find the circumference separately, or you could just use a formula that uses all of it together. That's my preference. So, let's undo that a little. Well, I guess I'll write it out with the circumference. So let's write 360 times 2 pi r. Okay, I just substituted the definition for circumference into that original equation there. Okay, now my arc measure here, for if I'm looking for arc length AE, I have to look at the degree measurement. So that would be 30 over 360 times 2 pi r. Oh, we know r is 4. Okay, so before we go on and actually solve for that, often you will be using pi and it will ask for an exact length. Just leave it in terms of pi as though pi were an x, and then you don't have to worry about it. You could multiply by 3.14 and get some decimal, but for our purposes, we're going to leave it in terms of pi, and I'll show you what that looks like. So we're going to simplify this a little bit. I can cross out those zeros. 3/36 is the same as 1/12 times 2 times 4 times pi. All right, well, this is like a numerator, right? Any number can be over 1. So I'm going to say 8 pi over 12. I just multiplied 1 times 2 times 4 times pi, and I left it in terms of pi. That's what I mean by in terms of pi. I'm leaving it with the pi in there so it's an exact form, knowing that if you needed an actual number, that you could use 3.14. And then 12 is my denominator, 12 times 1 here. Now, I could simplify this a little bit more because I could divide both of those by 4. I guess I could have simplified it up there a little bit. If you divide the top by 4 and the bottom by 4, you're really dividing by 1, which gives you the same thing. So I could have 2 pi thirds is how you would read that. And that is the arc length for AE. Okay, that's kind of the answer way up there, right here. Okay, arc length of CD. Well, let's zoom out a little bit. CD, wait a minute, CD, I don't even have an angle measure for. Definitely going to need that. So, can I find that? Do I have enough information? Well, I do, because I know that ABC was a straight, or is a straight line, which means all of these angles together have to add up to what? 180. Yes. So if I say that I have 180 and I'm going to subtract that 30 and that 20 from this section and this section here. That's going to be what remains, or this theta value there. Well, I know that 180 minus 50 would be 130. I think it's cut out, sorry. 130 degrees. Y'all get that? Okay, so if that's 130 degrees, now can I find the arc length? Yes. That is going to be a little bit easier. I need to have that. And again, I still need that radius there. Okay, so the arc length of CD, I know this is about the messiest page possible. I'm so sorry about that. All right, theta over 360 times 2 pi r. And I'm just going to jump right to 2 pi r because I know that I don't actually know the circumference. I just know the radius. So let's put 130 divided by 360 times 2 pi, and my radius is 4. So now I'm going to simplify this a little bit. I know I could cancel out my zeros. 13 is a prime number, so not much I can do there. But I know I am going to be multiplying it by 8 over 300, or it's just 36 now, okay? So I could simplify this a little. I could divide this by 4. We'll get 2 here and 9 here. So I'm going to have 26 pi over 9 just by multiplying that across. And there's really no other way I can simplify that. So this is the arc length of CD. All right, I hope that helps a little bit. Make sure you remember your units. I forgot that on both of these I didn't have units. This should be in inches or in centimeters, whatever it might be. Of course, those couldn't be different units of measurement for the same circle, but I would have to give you, maybe this was 4 inches. Now, your arc measures are going to be in degrees, and we're going to only work with degrees there. So if you have this degree symbol there, that's really all you need in terms of units. Okay, I hope that helped a little bit. That is arc measure and length. Tomorrow we're going to jump into 8.4 and then kind of go from there, and we will be beginning chapter 9 even next week. So take a look at that. It's all up on RenWeb already. But your assessment, that won't be until next Friday, not tomorrow, but the next Friday will only be over chapter 8. So I hope that this helped. I miss you guys. Can't wait to be with everyone again. Let me know if you have any questions. Have a great night.